All right, when dealing with astigmatism, any patient that has astigmatism, what we want to classify in, there are two ways we want to look at it. One, what type of astigmatism, and two, what's the orientation. So we're going to start with the types. Now we had a very, very, very thorough handout on this, but on our last quiz and in some of our homeworks, there is still a lot of confusion, so I want to recover this a little bit more carefully. So again, when you want to determine the type, there are three ways. There's the compound myopic astigmatism, compound hyperopic astigmatism, simple myopic astigmatism, simple hyperopic astigmatism, makes sense, and then you have your mixed. And actually I'll just do mixed astigmatism, just MA. So you should at this point be able to look at each of these. Now, these two are both compound, makes sense. These both are simple. And this is essentially split. And all that we're trying to do is look at both meridians on a lens. Remember, there's a sphere, there's a cyl. If you break down a spherocylindrical lens, there are always two primary powers. And what we want to do is look at each axis, each of the axes, and find out, is each axis, is it a plus lens? Is it a minus lens? Or is it plano? Those are only three options. So if you looked at a prescription and you look at both of its two primary meridians, is the first meridian plus or minus, or is it plano? Is the second plus or minus, or is it plano? And if you can determine that, you can tell me what type of astigmatism it is. And it's important because this is a skill that if you know how to put a prescription on a lens cross like we had done previously, if you know how to transpose a prescription, you can figure each of these out. So, plus minus plano, well, let's look into it. If you look at meridian 1, and 2, with a compound myopic astigmatic lens, a compound CMA, both are minus. So if I had an example, would be a minus 2, axis 180. As you can obviously see, one meridian is a minus 2. 90 degrees away, you get the sphere plus the cyl. So at 90 degrees, it's a minus 4. Well, I have a minus 2 in one meridian, a minus 4 in the other. They're both minus. Therefore, compound myopic astigmatism. If I have compound hyperopic astigmatism, both meridians are plus. So if I had a plus 6, minus 2, axis 180, if you look at each of those axes, axis 180, sphere, corresponds with a cyl. It's a plus 6 at 180. 90 degrees away, you have the full amount of cyl, which is only 2 diopters less. So it's a plus 6 in one meridian. It's a plus 4 in the other meridian. Each are plus. This would be a compound hyperopic astigmatic correction. Simple just means one meridian has to be plano. In both simple myopic astigmatism, one is plano. Simple hyperopic astigmatism, one is plano. But you can sort of guess where we're going. That means the other meridian has to be a minus for the simple myopic astigmatism. And for the simple hyperopic, well, one has to be a plus. It's sort of the definition. And this one, this is where I want you to watch out a little bit. Because this plano minus 2, axis 180, I have one meridian is plano, 90 degrees away is a minus 2. If one is plano and one is minus, this is simple myopic astigmatism. Now, simple hyperopic astigmatism, this one, watch out, it sometimes is almost counterintuitive, but if I have a plus 2, minus 2, axis 180, a lot of folks were saying well, I have a plus and I have a minus, so obviously it's mixed astigmatism or something. No, 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 no. Take a look at, in this meridian, the sphere corresponds with the axis. A +2, axis 180. 90 degrees away, however, you get an additional -2. So if you look at these two meridians, I have a +2 in one, a plano in the other. It's hyperopic or plus in one meridian, plano in the other, simple hyperopic astigmatism. A lot of people miss that one on the quiz, and I'll give you a couple more examples in a moment. So, and the last one is mixed astigmatism. If I have one that is plus and one that is minus, that would be mixed. So if I had a +2, -4, axis 180, I would have +2 at 180. 90 degrees away, I have the full amount of cylinder in addition to the sphere. It would be a -2 in the other meridian. So if I have a +2 in one, a -2 in the other, one's plus, one's minus, I have mixed astigmatism. So there's only 5 different ways you can have. If it is not one of these, that means it doesn't have cylinder. It means it's either a spherical lens or a plano lens, but anything that has cyl will fit into this. So, remember, compound myopic astigmatism, both meridians are minus. Compound hyperopic astigmatism, both meridians are plus. Simple myopic, simple hyperopic, one will plano, the other is myopic or hyperopic. And then the mixed, you just have one meridian is plus, one is minus. Now, to go into a little bit more detail about this, this is where you have to know how to transpose, or I suggest that you use your lens cross that we went over earlier. So let's go back to our trusty lens cross, and as we did before, here's 0, here's 90, here's 180. So let's give you a prescription, and we're going to argue it is a -4 +3 axis 40. Now, there are some folks that in our homework and in our quizzes, because one was a plus, one was a minus, they said that was mixed astigmatism. But be careful, it's not how it's written. I want to know what my 2 primary axes are. So one of the first things you can do is plot it on your lens cross, 40 degrees away. It is a -4. And this is at 40 degrees, pretty simple. 90 degrees away, which would be at 130. It is not a -4, but the sphere plus a cyl, and remember, adding algebraically, a -4 and a +3 would give me a -1. Well, if you look very carefully, I have a minus here, I have a minus here. This is a compound myopic astigmatism. Now, if you don't want to go through this whole trouble, and I like this because it makes sense to me, the other way you can actually look at it is simply transpose it. And what I want you to do is, you know that a -4 +3 axis 40 is the exact same thing as a -1. Add the 2 algebraically, change the sign, and go 90 degrees away. You either have to add 90 or subtract 90 as long as the final result is between 1 and 180. So, if you want to simply transpose, if it's in plus cyl or minus cyl, the first number of each will also be the equivalent of what your 2 primary meridians are. So if you simply take the prescription and transpose it, if the first number is minus, the second number is minus, that's another way to determine. You're doing the same thing as just putting in the lens cross, but I like doing the lens cross because it's easier for me to visualize. So let's do one more, and then we'll give you some more examples in problems. But here's our lens cross again, pretty straightforward, 0, 90, 180, and we'll just give, for kicks, a +4 -375 axis 150. So we're going to find at 150, about 30 degrees away from 80, at 150, we have a plus 4, 90 degrees away, which would be 60 degrees. We would have the full amount of the sill plus full amount of the sphere plus a sill plus 25. Well, since both are plus, this would be compound hyperopic astigmatism. Again, I want you to go back and read, for those of you who didn't get this 100%, I'd like you to go back and read our handout because it was actually very concise. But in this case, remember, it's not how it's written, it's what's the first meridian, what's the second meridian, and if you want to do that transposing trick, well, in this case, let's just transpose it and get rid of all my lens crosses if you don't need those, and simply transpose it. Plus 4 minus 375, add them algebraically, this would be plus a quarter, swap the sign, and then remember my trick for doing 90 degrees away, if it's a double digit, if it's a 3-digit number, add the 2, it's always 90 degrees away. So if I have this and this, these are my 2 primary meridians, they're both plus compound hyperopic astigmatism. And so let me give you an example of simple hyperopic astigmatism. Let's do plus 325, minus 325, axis 90. Transpose it. Plus 325 minus 325 is plano. Change the sign. 90 degrees away. One meridian.